So welcome everyone to one more new video in this series. Today what we are going to talk about is inductive effect, and we are going to wrap up our discussions on this electronic effects as a whole. We have touched on resonance, we have talked a little bit about hyperconjugation. Now we are going to talk about inductive effect. These three are the effects which are going to come handy when we go and discuss other aspects of organic chemistry such as acid bases and so on. So now let's discuss this inductive effect. So what is inductive effect? Broadly, this is denoted as I effect. We can have two types of it. One is plus I and one is minus I. Which one is something I am going to discuss. So first let us see, in case of homonuclear diatomic molecules such as hydrogen. What are homonuclear diatomics? Homonuclear diatomics are molecules which are composed of two atoms, that's why diatomics, and homonuclear means both of them are the same, H2, Cl2, like this. These are homonuclear diatomics. HBr, HCl, these are all heteronuclear diatomics. So in case of homonuclear diatomics, as you can understand, both of them have the same electronegativity. And you know very well that a covalent bond is formed by two electrons. One is shared by each of these atoms. So in case of homonuclear diatomics, since both of them have the same electronegativity, this electron cloud is not going to be shifted in this direction or in this direction. It is going to stay somewhere in the middle of both of these atoms. Whereas in case of heteronuclear diatomics, such as if you consider HCl, then although this bond has been formed by sharing of one of the electrons from hydrogen and one from chlorine, but still, since chlorine is way more electronegative as compared to hydrogen, it is going to attract the electron cloud towards itself. The same happens with HF or anything you consider, or any heteronuclear diatomics you consider. Where there is a difference in electronegativity, the more electronegative atom will definitely tend to attract the electron cloud towards itself. So when it tends to attract the electron cloud towards itself, what is going to happen is that this is definitely going to attain some kind of a delta negative character, and this a delta positive character. Remember this, the electron cloud is only partially drifted towards the more electronegative atom. There is no complete bond cleavage. The bond has not been broken. It's just that the electron cloud is now drifted towards the more electronegative atom, and that's why the more electronegative atom attains a delta negative charge and the electropositive one attains a delta positive charge. This is the case with all heteronuclear diatomics, and this is what is known as inductive effect. Why inductive effect? The more electronegative atom induces a partial delta negative charge on itself and the partial delta positive charge on the electropositive counter atom. I believe this is clear to you. The more electronegative atom is going to drift the electron cloud towards itself, and that's how it attains a delta negative charge. And since it has attained a delta negative charge, this hydrogen attains a delta positive charge because the electron cloud has now drifted away from it. Now what happens is that this one, the one which withdraws the electron, we say that this one has a minus I effect, and the one which donates the electron cloud is something we refer to as plus I effect. So what is it? In a very broad sense, the group which withdraws electrons towards itself is said to have a minus I effect, and the group which donates electron from itself is a group which is said to have a plus I effect. So Cl, because it withdraws electrons, has minus I effect, and H, because it donates electron, has a plus I effect. This is in a very broad sense. So now if you consider a molecule like this, suppose a molecule like this. In this case, bromine is more electronegative than carbon. So bromine is going to attain a delta negative charge, carbon is going to attain a delta positive charge. What we say is that this has a minus I effect and this has a plus I effect. I believe this is clear to you. Now one more aspect that is quite important in this regard is that if you suppose take a molecule like this, what happens is that first just consider this part. Just consider this part. In this case, bromine is more electronegative than carbon. So bromine is going to withdraw the electron cloud towards itself or drift the electron cloud towards itself. So it is going to attain a delta negative charge. And this one, because it has given away the electrons from itself, is going to attain a delta positive charge. Okay. Now what happens? This one, now let us consider the carbon adjoining to this carbon or adjacent to this carbon. This is going to have a delta positive charge. So what is it? So how can we explain this? Now it is something like this. This bromine is going to attract the electrons towards itself. The bond which is nearest to it is definitely going to contribute the most. So that's why the positive charge over this carbon is going to be the highest. Now this bromine, because of its electronegative character, will even withdraw electrons from this bond as well. Now since this is farthest away or farther away from this bond, the magnitude of positive charge over this carbon is definitely going to be less than this carbon. So the one which is adjacent to the electronegative bromine is going to have a more positive character. The carbon which is farther away from the electronegative bromine is going to have a lesser amount of positive charge. If you now consider one more carbon, so what is going to happen if you have one more carbon? This is quite understandable from this, that this is going to withdraw the electron. The more distant this from this, the lesser will be the charge induced by this on this carbon. Okay, since this is electronegative, this is going to withdraw. Okay, let me give you a very clean and clear example. Suppose you have a rotten potato in a bag. Okay, the potato is going to make all the potatoes bad eventually. So but how does it start? It is going to make the potato adjacent to it rotten first, and then consequently the potatoes away from it is going to get rotten at a slower rate. That's what happens here. The carbon which is adjacent to the electronegative bromine is going to bear or is going to acquire the most positive charge, and consequently once you go away from that carbon, the magnitude of positive charge is going to decrease. So in this case what happens? In this case, this one is going to attain a delta positive character, this one is going to, this is a little bit here, this is going to attain a delta positive character, this is going to attain a delta positive character. So this one is going to attain the least positive character, followed by this, and this one is going to have the most positive character because it is directly attached to this electronegative bromine atom. I believe this is clear. So what I wanted to tell from this is that inductive effect is actually distance dependent. So the nearer it is from the group which is actually inducing the effect, the greater the intensity of the effect is. Now in this case, if you do this, suppose if you do this, CH3, CHBr, CH2, CH. In this case, this carbon is going to attain the maximum delta positive character. This one is going to attain delta positive character. This one is also going to attain delta positive character because both of them are equidistant from this bromine. This one on the other hand is going to acquire the least amount of positive character. That's how it is. So it's actually a distance dependent phenomenon. That's what I'm trying to tell. Now let us see some groups which has plus I effect and minus I effect. So this is the list of groups which has plus I effect and this one minus I effect. This is the order of it. The order is not that important. Believe me, the order is not that important. But one thing that inevitably comes to your mind is that one thing you need to understand is that you see these are all positively charged things. Okay, positively charged things or groups are things which are definitely going to attract electrons. So these are groups which has minus I effect. That is, they are going to withdraw the electron cloud. So since they are going to withdraw the electron cloud, they have minus I effect, and positive charge over it actually enhances its probability or its capacity to withdraw electrons. In this case, just the reverse thing happens. Species or groups with minus charges actually have plus I effect because they have more electrons. Those are the electrons which this group wants to donate to others. So no group wants to keep charge on itself. It always wants to neutralize the charge. If it is a positively charged species, it is going to attract electrons and going to neutralize it. If it is a negatively charged species, it is going to donate its electrons and neutralize it. And remember one more thing, that generally alkyl groups have plus I effect. All alkyl groups have plus I effect. Now this question, I believe this question definitely comes to your mind, and please let me know of this answer in the comment section below. Or in this case, what I'm going to ask is that, in this case, if you understand, this is NR3. R means alkyl group. Okay, this might be methyl, this might be ethyl, whatever it is. This is NR3 and this is NH3 plus. Since nitrogen is tetravalent in this case, so we have a positive charge over nitrogen. So in this case, if you understand that both of them are positively charged species. Okay, positively charged species. In this case, if you see, these R groups have a plus I effect. That's what is being said here. So since these have a plus I effect, these are going to donate its electrons towards this positively charged nitrogen, and positively charged nitrogen will actually accept those electrons as well because it has a positive charge over it and it needs to neutralize it. So in this case, the plus I effect of this R group is definitely going to neutralize the positive charge over this nitrogen atom. So in this case, the positive charge over it is neutralized, whereas in this case, this small hydrogens doesn't have that much of plus I effect like the alkyl group, so it is not going to neutralize the positive charge over this nitrogen to that extent. So the charge density over this nitrogen should be greater than that of the charge density over nitrogen. In this case, is bound to be greater than the charge density of nitrogen, charge density over nitrogen in NR3. So what ideally should have happened? More the positive charge, more is the ability to drift the electrons towards itself. You have more deficiency of electrons, so since that is the reason why you are going to attract electrons to a greater extent towards itself. So ideally NH3 plus, because of its greater positive charge density over nitrogen, should have ideally dragged the electron cloud more towards itself. So this should have come ideally before NR3. This should have come before NR3, but this comes after NR3. NH3 plus is a weaker minus I effect group as compared to NR3 plus. I want to know the reason behind it. I have explained the ambiguity. What is the way you try to explain it, and that's where you actually fall into the trap. This is not the correct way of explaining it. Though whatever I said is right, but the answer to this is something different. Why does NR3 act as a strongly electron withdrawing group as compared to NH3 plus, though the positive charge density over NH3 plus is more than that of NR3 plus? Now, one more thing I need to say is that most of the functional groups you see, almost all of them are minus I effect groups. So all of them actually display minus I effect. Okay, so now let us see how inductive effect is helpful in explaining the stability of a few structures. So let us take the example of this. So if someone asks you whether this is more stable or this one is more stable, what will be your answer? Okay, now let us see. both of them will exhibit resonance. Remember one thing, the effect of resonance is way higher than the effect of inductive effect. Okay, resonance is a stronger effect than anything. Resonance is stronger than hyperconjugation. Resonance is stronger than inductive effect. So whenever you are given 2-3 structures and you have been asked stability of them, please see that whether resonance is going to happen in those systems or not. In this case, both of these systems definitely shows resonance. Let us draw the resonating structures. So how will the resonating structures be? I will draw the resonating structures of only one of them. You are going to draw another one and let us know if you have a problem. So in this case, see, the same protocol we are going to follow, top to middle, middle to top. We are going to get this. Plus here, this, and this. Now this negative charge has two options. It can go here, top to middle of this bond, middle to top of this. And one more thing it can undergo is that top to middle of this bond and middle to top of this atom. So what are we going to get? We are going to get two structures like this, one this, and one of them should be somewhat like this. Forgive me for my bad handwriting skills. So in this case, if you see that the same is going to happen with the other things as well, means that is this top to middle and this middle to top, this is going to happen. This is something which you know. Now if you can see this nitro group, in this case both of them are going to exhibit resonance. This one is going to exhibit resonance with the same number of resonating structures. This one is also going to exhibit resonance with the same number of resonating structures. Just that the negative charge will come here, and whatever we have drawn in this case here, we are going to draw here. So the nitro group in this case is withdrawing electrons from the ortho position. In case of this one, it is going to withdraw electrons from the para position when the negative charge comes to this position. So that is okay. We are going to get the same number of resonating structures in both the cases. But if you notice in this case, the electron withdrawing nitro group or the nitro group which has minus I effect is more closer to the atom which bears the negative charge. In this case, the nitro group is further away from the atom which bears the negative charge. So since inductive effect is a distance dependent phenomenon, the minus I effect will be far more higher in this case as compared to this, because this is residing closer to this negative charge as compared to this nitro group which resides further away from this negative charge. So because of this electron withdrawing effect of this nitro group which is closer to this minus charge, this is going to be more stable as compared to this, though resonance tells us that both of them are going to have the same number of resonating structures. And actually resonance cannot tell in this specific case which one is more stable than the other, because we are going to get same kind of resonating structures in both the cases. That's how inductive effect comes into play when we try to determine the stability of corresponding structures. We are going to see more of this in the upcoming videos, but this much for now. What you need to remember is just that which are the groups which exhibit plus I effect and which are the groups that exhibit minus I effect. Plus I will again repeat this, groups which have a positive charge will definitely try to withdraw electrons, that's why they will show minus I effect, and groups which have a negative charge, that is excess of electrons, they are going to donate the excess of electrons to other groups, so they are going to have plus I effect. And most of the functional groups you see has minus I effect. If you have liked the content, then please give it a thumbs up and don't forget to share and subscribe to this channel. Thank you.